Hi, welcome to xmTuition, where I help everyone with their physics homework. Like yesterday, I met this little girl at somebody's birthday party and she asked me to explain this question to her. So this question is about a longitudinal wave and we are shown the displacement distance graph of the wave at one instant in time. We are told that point P is a region of rarefaction. What does that mean? So let's consider the particle at point P and its two immediate neighbors on the left and the right. Let's say these are those three particles when they are at their equilibrium position. So this corresponds to the spacing for the particles centered at P if the displacement is 0 throughout. I repeat, if the displacement is 0 throughout, the three air particles centered about P are spaced this much apart. But the displacement is not 0 throughout, right? The displacement follows this graph here. So for point P to be a point of rarefaction, the particle on the left of P must be displaced further leftward, right? And the particle on the right must be displaced further rightward. Only then will these three particles be spaced further apart in order for this point to be a point of rarefaction. But notice this guy has a leftward displacement, but its displacement is represented by a positive number on the graph. What does that tell us? It means this graph is plotted with the sign convention of leftward is positive. Very tricky, Most of the time, people will take rightward to be positive, but the setter chose leftward to be positive, maybe just to trick students. So anyway, since we are at it, we might as well look at point Q and point R as well. So the three particles centered about Q will all be having negative displacement. Negative means rightward, So the three particles centered about Q will all be displaced to the right. So does that change the spacing between them? No, right? They end up the same distance apart. That's why at point Q, you don't have compression, you don't have rarefaction. It's just the average pressure. What about point R? On the left is a negative displacement. That means the particle on the left is displaced rightward. Remember, leftward is positive. So what happens at point R is the particle on the left is displaced rightward and the particle on the right is displaced leftward. What does that make R? It makes R very compressed. That's why R is a point of compression. But anyway, I've digressed, To solve this question, all you have to figure out is that the sign convention used is leftward is positive. So all these regions here have a positive displacement, which means all these particles here are displaced to their left and all these particles are displaced to their right. That's why the answer is D. I hope this little girl will continue to study physics. She looks very talented. Ta-ta!